So now I want to talk about solving absolute value inequalities. So there's a few rules we have to remember about absolute values. First, like I've said before, anytime you see an absolute value sign, you should think distance. You should think that at least on the one-dimensional case, you should think distance from zero on the number line. Okay. Um, let's go over a couple of rules here. Okay, if you for so okay, when we dealt with equalities before, we would have it equal to some distance. But if we're dealing with inequalities, we might have a range of values, multiple values. So if we have x is strictly less than c, okay, and in this case, c is going to be greater than or equal to zero uh, um, in all cases here. Okay. So we have x is, let's use a different variable. My c's look too much like my uh, inequality signs. Let's do x is less than, well, we'll use y. Okay, the absolute value of x is strictly less than y. This is equivalent to uh, negative y is less than x, which is less than positive y. Okay, all right. To understand a little bit about that, okay, we have, let's say, for in this case, let's let y equal 4. Okay, if y is 4, all right, so this would imply that we have the absolute value of x is less than 4. Okay, so we want all that. Really, what we're saying here is we want all values of x whose distance is less than 4 from 0 on the number line. Okay, so if we were to graph this, we would have 0. We want everything that's within a distance of 4. So we can go out 4 here. Okay, we're not going to include that point. And we can go 4 this way as well, which would be negative 4. And again, we're not going to include that point. All right, so that's kind of the intuition for that. So we'd end up with all values between negative 4 and positive 4 in this case. Okay, so that's our intuition for the absolute value of x being strictly less than y, being equivalent to saying we have negative y strictly less than x, which is strictly less than y. And it's very similar for the absolute value of x being less than or equal to y. It's the same idea. I won't graph this one, but you'll get the idea. Okay, it's the same graph as what I just did here, except you'd fill in the dots. That's the only difference here. Okay. Then we also have, if we have the absolute value of x is greater than y, this is equivalent to x is less than negative y, or x is greater than positive y. Okay, and again, the intuition here, let's say y is 4 again. Okay, so if we let y equal 4, then we have all values of x that are strictly greater than 4. So we're looking for all values of x whose distance is greater than 4 from 0. Okay, so let's go ahead and do this on the number line to show the intuition here. Okay, so let's say this is our origin, 0, and then we go out 4 here, and we can go out 4 in this direction. All right, so if we wanted to graph this, all values whose distance is greater than 4, keep in mind the word here is strictly greater than, so we'll do an open dot here and an open dot here. We'll have everything to the left here and everything to the right here. And this is because all these values have a distance greater than 4 from 0. okay? So that's how we come up with x is less than negative, there should be a negative sign here. X is less than negative y, or x is greater than positive y, okay? So you want all values that would satisfy either one of these, okay? And the same thing would go for x greater than or equal to y. Okay, and again, the graph is exactly the same, except you would just fill in the dots. There's nothing particularly different here about that. Okay. Now, in the situation where you have c less than 0, so here we said for all of these c, or we said in this case we have, or use y instead of c, but what if y is less than 0, okay? If you have if y is less than 0, then the absolute value of x strictly less than y and the absolute value of x less than or equal to y, they have no solution. And again, you can think of this intuitively. If you want to find all values of x who has a distance which is less than a negative number, that means that the distance would have to be a negative number, and that doesn't make any sense, right? So if y is strictly less than 0, then yeah, it's not going to work, okay? But if we say all values of x that are greater than y and all values of x that are greater than or equal to y, and you have some value of y that is strictly less than 0, this would be all real numbers, okay? That would be every number would satisfy that. If you all values of x that have a distance greater than y, where y is a negative number, well, that would trivially be true. Okay, so you would have all real numbers would be true for that. Okay, so let's go ahead and solve a few of these. Didn't space these out very well, but you get the idea. So here we have the absolute value of x minus 15 is strictly less than negative 8. So let's go ahead and add 15 to both sides. And we're going to end up with the absolute value of x is strictly less than 7. Okay, so taking a look at our rules here, 7 is positive. Okay, so we can look at our initial rules. So we have, this is going to be equivalent to, for the absolute value of x is strictly less than y. This is equivalent to saying we have, oh, there we go, sorry about that. This is equivalent to saying x is, sorry, we have negative 7 is less than x, which is less than 7. So we want all values of x that are within 7 on the number line. Okay, so we can leave it like this, or we can write it in interval notation, and also write it like negative 7 to 7. Either of these would be fine. Okay, you can graph this out if that makes it easier to see, but either way, this is how that would look. Okay, let's take a look at this one. We have the absolute value of y plus 10 is greater than or equal to 16. So let's take 10 away. So now we have the absolute value of y is greater than or equal to 6. So here what we're looking at is we want all values of y whose distance from 0 is greater than or equal to 6. So this would just end up being negative 6, or sorry, we have y is less than or equal to negative 6, or y is greater than or equal to positive 6. Okay, we're looking for all values all values of y whose distance is greater than or equal to 6 from 0. All right, now let's look at this one. we have the absolute value of x plus 16 is less than or equal to 11. So we can take 16 away. And we'll end up with the absolute value of x is less than or equal to -5. Okay, well, we know from our rules up here, if in this case we said y was less than 0, that means we're actually going to end up having no solution here. Okay, so really what this is saying is all values of x whose distance from 0 is less than or equal to -5. That statement doesn't even really make sense, so we have to say no solution here for this one. Okay, sometimes you'll end up with some kind of expression inside of the absolute value sign. So let's take a look at something like that. So here we have the absolute value of 6x minus 12 is strictly greater than 6. Okay, so we can write this as, we want all values of this expression that have a distance greater than 6. So we can write this as 6x minus 12 are strictly less than -6, or 6x minus 12 is strictly greater than +6. Okay, so let's solve each of these. So we'll add 12 to both sides, and we'll get 6x is strictly less than 6, divide by 6, and we'll get x is less than 1. And we can write this as -infinity to 1. All right, and then over here we have plus 12 plus 12, and we'll have 6x is strictly greater than, it looks like 18. Can divide both sides by 6, and we'll get x is strictly greater than 3. All right, so we can write this as 3 to infinity. All right, but remember, we want all values that satisfy either of these, not both at the same time, but either one. So we would actually just say our final answer is these two unioned together. So we have -infinity to 1 unioned with 3 to infinity. Or you can write this as a graph if you want. We can do that as well. All right, so we can say we have, we can write our relevant values down. We have 1, we have 3. All right, so we're not going to include the point 1. All right, so we do a little circle here, and we want everything strictly less than 1. And then here we want to not include the point 3, and we want everything strictly greater than 3. So there we go. That would also be a valid way of writing your answer here. I can't remember if Alex wants you to do it with interval notation or if they want you to do it with graphing, but you should be equipped then for either way. How about this one? Here we have -10 minus 2x is strictly less than 4. Okay, so in this case, we want everything. We can actually write this as -4 is strictly less than -10 minus 2x, which is less than +4. Okay, so you want everything, we want all values of this expression that are within a distance of 4 from 0. Okay, so to solve this, we have we have two inequality signs here. But what's nice about this is we can still solve it kind of the same way. But now instead of doing it to both sides, we have to do it to all sides, so to speak, okay? So let's say we want to try and isolate x in the middle here by itself. We follow the same basic rules. So let's go ahead and add 10 here. But to do that, we actually have to add 10 here, and we have to add 10 here. That's the only thing that's going to make this valid, okay? So these will disappear, and we'll have -4 plus 10. That'll give us a +6 is strictly less than -2x, which is strictly less than +14. Now we can divide both sides by, or all sides by -2. And keep in mind here, we have to flip our signs. So we're actually going to have -3 is strictly greater than x which is strictly greater than -7. All right, so you can leave it like this, or you can write this in interval notation. We want all values between -7 and -3 that don't include those endpoints. So we can also write this as -7 to -3. Or if we wanted to graph this, we could do that too. Draw our number line, write our relevant values. We have -7, we have -3. We would draw our endpoints here. We're not including them, so we do circles. We want everything between -7 and -3. This would also be a valid way of writing our answer. So depending on what Alex wants, you should have 3 different ways you can write it. All right, well, hopefully that makes compound inequalities make a little more sense. If you have any questions about this, please feel free to shoot me an email.